public transport keeps our cities moving, crowded and in high demand throughout the day. But at night, these vehicles stand still. While the streets fall silent, delivery trucks fill the empty roads, transporting goods from ports to urban distribution hubs. Two systems separated by time. One runs by day, the other by night, each using its own fleet, its own resources. A missed opportunity for smarter mobility. OMEX is the solution to this inefficiency. It's a modular vehicle that transports people during the day and goods at night. By combining two separate systems into one, OMEX makes better use of infrastructure. Each OMEX unit consists of two sub-vehicles that attach to either end of a container or passenger module. When idle or moving without a load, the sub-vehicles can connect into a compact, unified vehicle. To pick up cargo, an auxiliary support wheel extends for stability, and the integrated lift system raises the module from the ground. The sub-vehicles use a specially designed gripping mechanism to connect to the ISO corners of a freight container, or to custom passenger cabins equipped with the same connection points. Thanks to the low-floor design, the passenger cabin of a bus can be lowered all the way to the ground, making it much easier for people with mobility impairments to board. The OMEX sub-vehicles are height adjustable thanks to an actuator and a deflection joint. The suspension remains functional in both the lowered and standard driving position. A second actuator at the rear controls the gripping mechanism for container attachment. The vehicle's paneling is designed to channel airflow through the radiators in both driving directions. Swappable battery modules ensure continuous 24/7 operation without downtime. The conception of OMEX was done using a bottom-up process, utilizing the ISO standard for overseas containers as the building block for the concept. After brainstorming and ideating in a sketchbook, the two-dimensional mechanical concepts were evaluated in an interactive, playful and creative process using Lego. The technical pieces, like spring suspensions, helped to understand the transfer of power in the system. With this gained knowledge, the mechanisms were improved and strengthened. As a consequence, the conversion to the CAD model was seamless and time-efficient. The needed mechanical parts were modeled and connected using constraints. This allowed an even more precise evaluation of the system and showed errors that were then fixed. The aerodynamic paneling and the bus cabin were designed using virtual reality software for real three-dimensional understanding of the shapes and spaces. OMEX redefines how we move people and goods with one intelligent, sustainable system. It's a bold step toward a future where mobility is more efficient, adaptable, and responsible.